Hello, 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 hello. Hello, good evening. And this is a Monday evening video recording. And we have a viewer submitted request. No? So I will be planning to have like viewer submitted requests from my Discord or from my community. Okay, right now I will put my community or I will put the link of where you can like talk to me about it. But yeah, so basically this is a viewer request. That's all. And I'm gonna start with modern atomic theory, although we're starting with chapter 11. Okay, and this is a little different from our previous videos because this is chemistry. Okay, chemistry. And well, my background is I'm a chemical engineer, and I have some idea about chemistry too. And I think I have like a very large chemistry is a very large part of our course, our studies, right? So basically, let's go let's go to our modern atomic theory. When we say modern atomic theory, I'm just gonna like copy this. Oh, you guys didn't see that. I'm gonna copy this. So when we say modern atomic theory, okay, so we chemists or we scientists, we view the world differently. Right? So instead of viewing like an object normally, we view them with atoms. Okay? So instead of we're seeing water, we're seeing the atoms inside the water. Right? And I think it's Democritus who first found it, who first coined the word atoms, where what if the smallest object, what is the smallest object that cannot be cut, right? Which is atoms, right? But as time goes by, we're not gonna focus on the names. We're not gonna focus on the people. But those are Democritus is a very popular Greek philosopher. Okay? But as time goes by, people found or people thought or people like discovered that an atom or modern atomic theory, right? So we're going to the modern, an atom can be divided into parts. Okay? There are more smaller parts in an atom, okay? Negative, positive, and blank or neutral. Okay? And you probably guys have already noticed this is the electron, the proton, okay, the neutron. Okay? So we're not in the modern yet, but basically this is the basis of an atom. Okay? Okay. And we're gonna go larger than an atom. Okay, before we go deeper into these smaller parts, let's go bigger than an atom, which is a molecule. Okay? A molecule or an element. Right? Okay. So when we say an element, let's say oxygen. That's an element. Hydrogen. Okay. So we have like the periodic table. We have like a lot of elements, 100 plus. We're discovering them. Although most of the heavier element are radioactive. Okay, some are metallic, some are organic, some are noble gases. Right? You guys might not know this yet, but basically some are solid in nature, some are water in nature or liquid in nature, some are gas in nature. Okay? Molecule. Okay. So let's go back to the smaller parts. So in atomic theory, in modern atomic theory, here's the proof. Noble gases, halogens, alkali metals. Okay? So in this atomic theory, the theory is depending on the combination, okay, without combination, number, how many, or pattern, okay, depending on the combination of these three, it can make up an oxygen, okay? It can make up an oxygen, it can make up hydrogen, it can make up the molecule, okay? So at first, people are like saying that there's the pattern is like the pattern or the movement is like there's a meaning about the pattern and the movement. Okay, they don't know how to draw it yet. They don't know how to visualize an atom yet. So one of these people, I think it's let's see, Rutherford. Yeah, see, there's a drawing here. Okay, so Rutherford's atom. One of these people is Rutherford, and another one is Bohr. Another one is Bohr, where they both make sense. Right? They both have their. I think another one is Bohr. See. So there's like a Bohr model and Rutherford's atom. Alright, so but let's focus on Rutherford's first. Okay, so Rutherford focus on the negative and positive. Okay, so Rutherford focus on the negative and positive. So basically on Rutherford, there's like a positive core. This is the positive core. There's a positive core in the middle which contains positive and neutral. Okay, so we know that magnets, right? For example, magnet, the same repel, right? When we play with magnets in experiments or in our refrigerator, when the same side repel or they go off, went away from each other, and opposite magnets attracts. Okay, so the core or the middle of the atoms is positively charged, okay, with neutral charge atoms inside, separating the positively charged, so the positive charge won't repel each other. Okay, along with negative charge or electrons on the outside. Okay, along with the negative charge on the outside. Okay, so one thing to take note here is a proton is larger in mass, right, than electron. Okay, if you guys use a calculator, you guys can find the mass of electron, okay, and proton in the calculator. The neutron's mass is almost the same as neutron or as proton, right? They have almost the same as proton. Okay, almost the same, but like it's like nth decimal, 10th decimal difference, right? Almost the same. Okay, but electron is the one who's like vastly or 1,000 digits more smaller and more lighter than electron, right? So what happens is the larger core, or like the sun, who's like very like the solar system, the larger cores in the middle gets surrounded by the electron, who's like very light, not like the planets in our solar system. Okay, so that's what Rutherford is talking about, right? Right. So the concept of a nuclear atom, okay, where in the middle are protons, okay, and the electrons might revolve around the nucleus. Okay, I'm not gonna read this. I'm just gonna try to explain this. Okay, but because electrons are very light, the theory is they're very light, super light. I mean, they're very small, times 10 to the negative 27 milligram. something like that. I'm not gonna get specific. If you guys want to know, it's in the calculator. Okay. Okay. So because they are very small, they move very fast. Okay. They move very fast. Also the proton. Okay. They move very fast. The idea is everything on Earth moves or vibrates in a kinetic electromagnetic way. Okay. It vibrates in a certain frequency, like the flash. Okay, solid vibrates, liquid vibrates, gas vibrates. Okay, but these electrons are very fast. Okay, so the term here is it might revolve around the nucleus, because in Rutherford's atom, the whole area outside the core, this one, I'm gonna put it at red. Okay, the whole area around the atom is a whole electron bubble. Okay, that where we call where they explain it that we cannot know what the position of the electron is, but we know that the electron is in there and it's moving very fast. Okay, and it's moving very fast. We don't know the position, so that's the word might right there be. Okay, it's moving very fast. Okay, that's the key term there. Okay, so because it's moving very fast, okay, very small, very fast, think of it this way, right? Oh, a car is moving very fast. It needs fuel, right? So anything that moves or vibrates requires energy to move, right? And the thing is, on these atoms, we're not talking any element yet. We're just talking of one atom. We could say it's just hydrogen, right? The thing is, with just hydrogen, okay, trying to separate these very small atoms, okay, that's just hydrogen, right? So hydrogen, I'm just gonna tell you right away. Hydrogen contains one proton, one electron. Okay. Okay. Hydrogen contains one proton, one electron. Okay. One. Okay. So this hydrogen has the least amount of cars, the least amount of atoms. Okay. And these atoms move very fast and has a lot of energy in them. Okay. And we might call them electromagnetic because they have like positive and negative, but we coin them, or basically we rename them into nucleus, nuclear energy, or basically it's the energy inside the atom. Okay, but basically, okay, there's energy containing or making the atoms move in an atom, in a atom, in a molecule. There's energy making it move. Okay, so I don't know how, I don't know why, but it is what it is. They have lots of energy. Okay, it has a lot of energy. Right, so the electromagnetic radiation, nuclear energy, these are the key terms. I'm not gonna try to read them, but it is in the name. So what is good in chemistry or in science, that the name itself is basically the meaning, wavelength, frequency. Okay, so let's move it down. Let's move it down. Right, here it is. Okay, so there is a lot of energy making them move, and in order to make them move away from its natural order, maybe it's like a waterfall, maybe in a waterfall, right, in a waterfall, water is falling, of course, right? But if you're going to stop the water from flowing, or you want to move the water into another way, or maybe a boulder going downward, a boulder going downward a mountain. If you want to stop that, you need a lot of energy. So in order to move a molecule with so small space, you need a lot of energy, right? That's why we have, probably you have watched other science fiction stuff, or probably you heard of hydrogen bomb, nuclear bomb. Okay, so these atoms, okay, in order to move them, okay, let's say we want to move the electron in a hydrogen atom or the proton in a hydrogen atom, because the electron is so fast, it's moving like very fast. We don't know the location. The nucleus or the proton is in the center. It's the only one who's not moving. Most of the time, the proton is the one we're aiming at when we're trying to move the proton or an atom, right? And moving this atom requires energy, and releasing it, or actually the term is emission. And the emission of this energy will also result into greater energy, right? So I'm not gonna explain more. Okay, I'm gonna stop right here. I want it to be short. Yeah, but I'm just so basically, I'm hoping a little storytelling will make it easier. If you guys read the book, right? A little storytelling makes it easier if you guys read the book, if you guys read what's in the notes, right? Sometimes when you just read the lesson, it's just very boring, right? So anyways, if you guys want me to focus on how to do stuff, probably compute the energy, maybe you guys message me. Okay, you guys message me on my Discord. If you guys want me to like analyze or explain how do we know how many atoms, what comes out from an atom, or what are the levels of going out, probably. Okay, what is Bohr model? We're gonna explain it more, right? Anyway, so this is a very productive evening for me. I hope you guys learned something, or you guys have at least enlightened, right, about my short story. Is it a short story? Anyways, thank you so much, guys. If you like the video, if you guys learn something, don't forget to like and subscribe, and thank you so much for watching again. See you guys for more. Bye. Bye, guys.